Hi, welcome to the lecture on Chapter 10, Wireless Wide Area Network, or probably better known as what system your telephone's working on, your cell phone's working on. So, we're going to talk about basic concepts of cellular telephony, how it works, different phases, or in this case, generations. You've heard of 3G, 4G, 4G LTE. You've heard of a lot of different terminologies. So we're going to talk about the evolution of the cellular network. And then, of course, discuss satellites and how they've been used for this wide area wireless networks. So cellular telephony, it's been pretty much in my career. Try to think about, probably been in cellular telephony probably since 2001-ish. No, take that back. 1991, 92. When telephony has really started taking off the cell phone industry. Now, I don't know if you remember back, the size of a cell phone used to be almost the size of a football. And if you wanted to have a mobile phone, you actually put a box in the back of your trunk of your car to be able to make a phone call on the road. So it has advanced a lot since now you look at your phone and say, everything I've got is sitting here. I can talk indoors, outdoors, on the road, capture the internet. So it has come a long way, and that's really what we're going to talk about today. So we all know that cell phones are quickly changing. How many of you have gotten rid of your your landline phones? I did. Probably been half a dozen years or so. The only number you got for me is my cell phone. The technology to make these things work is probably, out of all the wireless technology that we've talked about, and some of it, based on the comments you've heard, it is fairly highly technical. And this one is probably more complex than all of them. So we're not going to get into a lot of the the details of how it works, but we're going to talk about what it, just on a high level, a little bit of history and stuff. And the governments like it too because they own the airways. They own the spectrum that can be used. And when your hand phone back in the mid-90s, when your cell phones went to what they called personal communication services, PCS, getting that 1.8 gigahertz range for frequencies, companies were bidding, when the government auctioned off that spectrum, they were bidding billions of dollars for just a city to be able to cover this. So it was great for the government. The companies needed it because they wanted service. And there was quite a few people out there who said, hey, I can make some money at this. So it's changed a lot. So today, practically all our cell phones are based digital instead of analog. It definitely did start analog back in the early 90s, late 80s. But today, most of it is digital. You've used your smartphone probably this morning for checking the weather, checking your email, catching up with friends, actually maybe making a call, So it has been used probably more than your PC. Now, the question is, how does it work? Well, the key to cellular telecommunication is what they call a cell. And a cell is basically a set of antennas which last week you went out and engineered and kind of highlighted where you would locate a cellular tower or antennas either in a city or on rooftops. But a cell basically either covers a couple thousand feet up to 10 miles. I've had cell sites in Arizona that with the correct antenna, we were covering like 24, 25 miles. So you're doing a lot of engineering to try to maximize that coverage footprint. Now, at the center of this cell is a transmitter receiver. And all of those base stations or all those towers connect back to a switch, mobile telecommunications switching office. And then, of course, that switching office is what connects us to the landline system. Just give you a rough idea. You can see, here's your switching tower, all your different towers connecting back to a switch, which then gets back into the private switch telephone network. Now, you got transmitters and cell towers. They all operate at very low power. When cell phones first came out, you were broadcasting at 3 watts of power in your cell phone. They were huge, heated up a lot. Battery didn't last very long. Now you're probably talking in fractions of milliwatts. So it expending battery life, but it also means I've got to be closer to because I can't transmit as far. So now I got to have my towers closer together. Now each of your cell phones have special codes. Actually, you probably got what you call a SIM card or some kind of information let's just give you an idea on how to identify who you are to the network. They range in size, how much memory they contain, what information's contained on them, and whether you can move the card between one phone and another using, without reprogramming the phones. A couple of different types, and different identification numbers that are included in it, ranging from a system identifier, which identifies the carrier, to an electronic serial number, which says it's my cell phone's unique serial number. But of course, that's not used with a SIM card. If it's an international phone, you got an international mobile equipment identifier. And then, of course, you've got a mobile identification number. So all of these numbers are used in one way, shape, or form in today's cell phones. Now, it's great when you look at we talk about Wi-Fi stuff and love the mobility. You love being able to move your cell phone, your laptop anywhere in the office. But the cell phone says, hey, now if I'm on the same phone call and I don't move around a lot, so I'm on campus using my phone, I am probably hooked up to the same base station transmitter cell tower for the entire call. But when I'm driving home, since a tower probably only covers, let's say, 1.5 miles, well, I've got a 12-mile ride home. I'm going to go through at least a half a dozen different towers. But in a lot of cases, I've talked to my wife the whole way home. And as I'm moving home, I'm handing off. I'm transitioning my call from one tower to another. Now, it used to be, you still roam, you go from one network to another provider to another. It's called roaming when I move that from one cellular network to another. And it used to be that the cost between going to those networks used to be astronomical. Well, now they've come up with agreements and that you're pretty much going between networks. You can't even tell. You never get a bill for it. So moving from one network to another, that means I'm roaming. Going from one cell to another, I'm handing off between the cell towers. Now, I'm not going to go through this whole list on how to receive a call, but as you can tell, we've done 3-way handoffs to make a connection in your NET175 class. You can tell here there's about half a dozen steps that just to receive a call is making sure that your cell phone knows what network it's on. It compares your identification with the call that's coming in to make sure that you're talking to the right person. Make sure you're the same network. Oh, okay, I got to determine if it's roaming or not. So when the call comes in, I've got the switch has got to locate you through a registration request. So it becomes fairly complicated. You see the picture of the 6 different steps that's being used to go through that. So let's look at the evolution of cellular. My technical career probably lasted about 3.5 of these. I'm not going to go through the details, but you can just know that when you're saying, hey, we're at 5G, LTE, moving to 5G, you're talking about major changes to telling a provider, a telephone provider, that now you got to change out all your cost, all the equipment you built and got some money out of. So you had the first generation, and basically they were based on advanced mobile services. They operated at a relatively low frequency, and they had channels that were certain width, 30K with a passband filter, which would use a frequency division. So we kind of divided the frequencies. Not a big deal. But it all used circuit switching technology. So each channel had a different frequency, and similar to what you do with your radio, right? Second generation came through and says, now I'm going to increase how much my data rates. Because people says, hey, I can talk, but I want to start sending data, which then says how many of you like to have slow response time on accessing the internet? The answer, none of us do. So now I started saying, hey, I'm still going to try to increase the frequencies. So now I've got 800 megahertz to the 1.9 gigahertz range. So now I'm starting getting into that higher frequency range that the government's auctioned off and people spent billions of dollars on. But they used digital. They were still circuit switching. But the digital transmissions used the frequencies a little bit more efficiently. I could go over long distance. The quality of voice didn't degrade. And it was difficult to decode, so I had a little better security. I definitely used less power, so now I can reduce the size of the handset so that the original cell phones back it started in the 80s where they were 3 watts, and then it went down to like 600 milliwatts. So it became a whole lot less, use less power, smaller. They could actually fit in your pocket. Some of the technologies, and we've talked about some of these, you had TDMA, CDMA, and GSM, which basically was a combination of frequency and time division. Just to give you a rough idea of TDMA, time division, it's all time division based on which time slot you got. We've talked about CDMA. It's a broadband spectrum. Now, while evolutions were changing, there was kind of an interim step between 2G and 3G, and that was 2.5G. It just took longer to come up with that new generation. But the difference basically is now my networks are packet switched instead of being circuit switched. Of course, packet switching now allows me to handle more efficient in handling data transmissions, and it pretty much allowed an all-on type technology. Now, there was 3 different types of 2.5G. You got one that's a general packet radio service. That's for TDMA and GSM systems. You had the enhanced data rates, Edge for the GSM systems, and you had CDMA 2000 1XRT, which allowed them to move up to the circuit switch. Now, the 3rd generation was intended to start standardizing uniform global standard across all the cellular systems. allowed better data rates, started standardizing some, and it's based on which evolution you were coming from as to what that next system you went to. So if you were coming from a CDMA 2000 1X RTT, you went to the 1X EVDO network. If you were looking for the 2G edge networks, you went to the wideband CDMA, and then most of it went to the high-speed downlink packet access. So it basically used the 5 megahertz. But now you start looking at, hey, I've got MIMO antennas start using. So the things that we saw in the wired, your wireless LAN are now starting to use on the outside. Now, you had higher speed, so you had an evolved high speed successor, basically had higher data rates, but it also gave an upgrade path to LTE, which is what the current, now you look at everything's, I want to make sure you see the advertising. So I'm going to go LTE. Basically, it's that new 4G. That's that next wave. That's the current wave that everybody's migrating to at the moment, which now gives you maximum down rate speeds up to 1 gigabit. So you're starting to approach landline speeds in today's environment. Now, it definitely uses what? Orthogonal frequency division multiple access. So it starts using some of the technologies that we've talked about on the wireless LAN. Now they're trying to, cellular networks are trying to go worldwide, trying to upgrade to voice over LTE. So it's trying to include this. So we're right now sitting right here in this stage, and you're probably going to see a lot of advertising. And you've seen 5G marketed and advertised. That's what's coming. So it's still being played out. The standards are still being written, but it's getting to the point where you're going to see a lot of change in the wireless world as far as what could happen. It's still not approved, still being tested. It's going to have a blend of all the technologies that we've talked about. You'll probably have some radios that actually can learn and adapt to the RF environment. So now you're getting really intelligent on the radio side to compensate for what's going on. You've heard probably talk on 5G to where your cars will be able to network along the highway. So it definitely has a totally different look as to what wireless could be in the upcoming years. Just a rough history as to the technology and what your data rates is. But if you look at the last few, we're starting getting landline speeds or even faster than landline in a lot of cases in a wireless network. So the ease of wanting to get rid of your landline phone and replace your wireless technology is becoming very, very appealing. So what do you see as the challenges in the outlook? Definitely it's significantly changed. If 5G is successful, it'll probably get rid of your wired network, because you got to think that a lot of the underdeveloped countries don't have a wired infrastructure. It's just a lot of the developed countries that had telephone companies wiring up your houses. All that becomes probably not necessary. Definitely your carriers are still going to spend a lot of money in maintaining that system, and if they don't have to, if they get more people onto 5G and I don't need the wired network, they'll stop maintaining it, and you won't reduce some of their costs that it takes. Now, next wireless advantage is broadband one is for satellite. Now we know that your satellite's used for GPS, so they can locate you anywhere you want. Satellite communication kind of falls into 3 different broad categories. One for acquire scientific data from research in space. or it's looking down at Earth and gathering information from Earth, or it's used to reflect bounce data back and forth and relay signals from one point on the Earth to another. And this is where the wireless communication can fall into that category. Just give you a rough idea, but this is the one that we use if you're using a satellite to be communicating wirelessly. Now, the transmissions that satellites use usually fall into one of the frequency bands, and whether it's the L, C band, KU, or KA, basically it is what frequency are they operating at. And of course, the frequency that you're operating at increases or changes the size of the antennas, ranging from, 30 inches to 146 inches. So it's not something I want to put in my back pocket and kind of carry with me. Now, the class or type of service pretty much falls into two categories: consumer and business. Consumer says I'm going to share it between other consumers. Business says I've probably got dedicated channels. Definitely more expensive, but it gives you a whole lot more security. Now, the type of connectivity, you've seen that in your Net 125, 126 classes: point-to-point, point-to-multipoint, and multi-point to multi-point. So allows me to communicate multiple different ways with people on the planet. Now, satellite transmissions has different modulation techniques, but you'll all see that they all are equivalent to what we've seen in all the discussions we've had in this chapter, whether it's from binary shift keying all the way down to the 16-level quadular amplitude modulation, or the 16 QAM. So all of it is stuff that we've seen before. Now, multiplexing techniques, they basically imply two: frequency division multiplexing and time division multiplexing. And then it's all outside of the scope of this class, but basically there are four basic that are being used, from permanently assigned to demand assigned multiple access. So you've got different choices, but they're definitely outside the scope of this class. Now, as far as satellites are concerned, there are three different types of classes, based on the orbit they have. They got low Earth orbit, medium, or high Earth. The high Earth, you may have heard it as a geosynchronous orbit, where it just kind of remains stationary over. It looks like it's stationary over top of the Earth. Now, the low Earth, altitude between 200 and 900, travel at high speeds, so they're not pulled back into the Earth's atmosphere. But being closer, the footprint is relatively small. But the advantage is I've got low latency between, so the round trip time between Earth and satellite is 20 to 40 milliseconds. So it's potentially usable for systems. Give you an idea of one of them. So they're used for pagers, satellite telephone, location services. So could be in demand in the future for rural conventional telephone, global mobile telephone, or international broadband services. Now, medium Earth orbit, a little higher, between 1,500 and 10,000 miles. But, so it's kind of like used for, they don't have to travel as much. So I get a larger footprint. As you can see, I get a whole larger footprint, so I don't need as many of the satellites. But now I've increased the latency, round trip between 50 and 150 milliseconds. So, maybe not what you need. Now you've got high Earth. This is now I can get good coverage. Typically orbits in about 24 hours. But the geosynchronous is sitting stationed about 22,000 miles over the Earth. It matches the rotation of the Earth, so it almost looks like it's stationary. And it provides a large service footprint. Basically need 3 of these satellites to cover the entire Earth. But here you got the latency of 250 milliseconds. So most of us probably wouldn't want that kind of delay in our conversations or transmitting data. So, rough idea there. So just summarization is the classification, advantages and disadvantages. Now, there are some experimental things going on. NASA has experimented with ultra-lightweight, solar-powered, high-flying aircraft. Google has launched experimental balloons that travel in the jet stream. Facebook's looking at solar-powered drones. But they're trying to, Google and Facebook are trying to, how cost-effectively can I get connectivity, internet connectivity to their users? You wonder why. Now, the Outlook satellites, yeah, it can provide wireless communication that may not be covered by other wireless, wide area networks. Enables the carriers to allow internet access to and voice calls on passengers of phone, airlines, ships, things of that nature that never hadn't been done in a long time. And of course, it'll probably evolve as things, as technology evolves and the cost of technology changes, and of course, the cost of reducing costs. So in this chapter, we've looked at a couple of different wide area network, cell phone, cellular telephony and satellite communications. So just take a look. Definitely we've gone through the entire generational list from 1G all the way to 5G. Talk about the different types of satellites, their orbits. So hopefully this gives you a rough idea on where the wireless, where your cell phone is going, and how it's going to be used in the technology, a little bit of the technology behind it. And you can kind of get an appreciation of how complex your cell phone really is. Hope you enjoyed the lecture. Have a nice day. Bye-bye.